a lot of the info I'm going to be presenting here covers a wide range of storages. There's not much difference, but I'll try and highlight what's different for the sunny issues that we've got. Unfortunately, some of the data I have is all based on wheat, but there is no data really out there at the moment for the sunnies. They're trying to generate it at the moment. Phil Burrell's doing some work up in Queensland. So forgive the graphs, they say wheat, but it's basically the same for sunnies as well. The main objective of storing, I mean, you're trying to maintain your quality. You've got to remember seeds are a live thing. They're going to degenerate, so you're trying to minimise that as possible and maintain quality. You want the ability to control insects, both physical damage caused by the insects, and they can also change if they get into large numbers, microclimates. So they can actually cause moisture problems and heat problems as well within the storage. And you also want to control the storage, be able to control the conditions within the storage to ensure that the conditions are right for the quality of the seed. And especially for oil seeds, that's very important. You want them cool and dry. As you can see here, and this is module 7 in case no one hasn't realised. Basically, 40% oil content you're trying to get reduced down to 9% moisture content. Oil seeds are big, and half of that seed is basically taken up with oil. You've got to remember oil and water don't mix, so all that moisture content is actually concentrated in about half the seed, and that can cause some storage issues. That's why we'd like it dry. The best bet for storing sunny seed on farm would most probably be a cone-based silo that's sealable and gas tight, so you can fumigate it, and we'll get into that in a minute, and also with aeration, so you can actually control the conditions. And the cone base is actually for hygiene issues because they're the easiest ones to clean. Go to the next slide on that. Insects love storages. It's sheltered, there's warmth, there's plenty of food, moisture, so they're quite happy to live there. For control, you need to remember a couple of things about insect life stages. There's 4 life stages to an insect. And the egg and the pupa, the 2 bits that are hardest to see, are actually the ones that are hardest to kill. So often you do a fumigation, you think you've killed, target these guys, you can't see these anymore, they're all dead, you think you've done a wonderful job, you re-infest it in a couple of weeks or less, and it's basically these guys you haven't killed, they're hatching. And another thing to remember is they are mobile, they will move. If the conditions aren't right, they will move. If you're monitoring and it's early, cold morning, they're not going to be down near the chute where it's cold, they're going to be somewhere in the middle. So think of that when you're actually looking for them. They're also mobile in that they will move between storages. So you want to have whole farm hygiene as well. They can move from miles away into the storages. So remember that they are mobile, and you're actually targeting eggs and pupa stages to try and kill, and that's what the labels are all about on your chemicals that are available. The main insects that you're going to find in sunflowers are lucky for sunflowers, they're basically secondary feeders. They don't actually damage the seed. And one of the main ones is the rust red flower beetle, quite a large beetle in stored grain terms. We're mostly talking 3 to 5 mils in size. Fairly reddish and quite mobile. You'll actually see it quite well. They like to sit at the top, quite often at the top of the grain bulk, the seed bulk. Moths, Indian meal moth would be the most common one. It's a 2-tone one. You might have actually noticed them in your kitchen pantries as well. Their main issue is this webbing. They can actually cause quite thick webbing, which can interrupt your machinery, as well as just causing havoc in your seed. And you get the larval stages in there often, just climbing around. You get other moths, the warehouse moths, and you get soakers. These are tiny little things, 1 millimetre long, very mobile, flat, slightly translucent. But these can actually build up to such a number, so when you look in your storage, it looks like it's moving. They can build up numbers when the conditions are right very quickly, and they are absolute bastards to get rid of. We don't like dealing with them at all. Other insect pests that you may find, remember insects are mobile. If you have them in a storage next to it, they can actually move. They're not the most common in sunflowers, but they will. You often can find them in secondary sort of infestations. Your lesser grain borer and your rice weevil, these are actually both primary feeders. They will actually live part of its life cycle in the seed, and they will cause holes. So they're actually damaging your seed. Flat grain beetle or Cryptolestes, smaller than the, similar colour to the rust red flower beetle, longer antenna, flatter by the name, and they're called Cryptolestes because they're quite cryptic, they hide. You don't see them very often, quite mobile though. Issues we have with those is phosphine resistance at the moment. I'll get onto that later. And sawtooth grain beetle, they've got little projections on the thorax. We've all talked, all three of us have now mentioned integrated. Use all your options available in order to control both insects and seed quality. For sunflower seeds in grain storage, your primary options are non-chemical. The monitoring, hygiene and aeration, I'll go through these in a bit. Chemicals, very few. Listed dusts here as a chemical, they're actually not technically a toxic chemical, they are inert and they can be used in organics. Very good, and I'd say an example of a dust is dry side. It's a structural treatment. You can apply it into your sunnies, but then you can't sell your sunnies away, so it's only for an on-farm treatment and it's quite expensive. So basically it's the best structural treatment you've got out there, even for non-organic people. Insecticides, no contact insecticides are allowed on any oil seeds, so that's canola as well as sunflower seeds. So no contact insecticides. There are some spray, natural-based pyrethrum sprays out there for misting and fogging for moth control and structural sprays, but do not apply them to the grain. And do not apply any structural OPs such as phenetrypthione to your storage that you are going to then store oil seeds in, because they will absorb it. Oil seeds are highly absorptive and they will take the active ingredient. And we've had problem issues in export markets where oil seeds have been sent back because they've had MRL, they found phenetrypthione basically in the seed and Japan said, no, back. If you have insect problems, fumigation is your only alternative. I'll talk about this later, hopefully if there's time, if I get through this quickly. When required, do it well, we'll get onto that. The thing about fumigation, and it's with phosphine, sulfuryl fluoride, ethyl formate or CO2 for organic people, nitrogen, they all require sealed, gas-tight storages. Otherwise, they just don't kill those eggs. Non-chemical. First of all, the monitoring. If you do find insects, it takes time to treat them with fumigation. Shortest time fumigation is 7 days fumigating, and then there's venting and withholding. So you're looking basically at 2 weeks overall. So you need to know prior to someone coming to buy the seed. I get so many calls saying, he's coming, what do I do? And I've got to say, send him away, because you can't treat them. You can't get rid of the insects in that time. So get into a regular routine, especially over summer where it's hot and you're storing seeds. Make sure you're checking that once a week or once a fortnight. Check at the top where the insects are found, if you can get up to the top. Also check at the bottom near the exit points of the grain, from the silo, so the bag chutes and those sort of points. That's where you'll most likely find insects. Sieve for them, they're small, especially the soakers. So get a sieve out there and have a good check. While you're there, also look at the condition of the seed. Check for hot spots, condensation, moulds, smells. So look for signs of damage. It's just an all-round strategy of checking your grain on a regular basis. Hygiene, one of the most important tools. We like to say it doesn't cost you anything, but it does. It's costing you time. But if you don't use it, you're most probably going to have more problems than you would if you didn't. Keep the whole farm clean. Insects are mobile, as I said, they migrate in from kilometres away. Don't make it easy for them by they're looking for food. There's a pile there, straight down. They'll migrate between storages, so make sure it's clean in there. Also, when you're emptying out your storage, ensure that it's clean to make sure that they don't reside in there in dust. It doesn't take much grain for an insect to live in, and eggs especially are able to survive long times without, obviously they're not eating, but eggs, they stay in the egg stage until the conditions are right and they will hatch. Don't forget about your equipment as well. Your harvester is one of the main things. Kevin mentioned the fact that, in ways that you can try and stop having the insects prior to it, you can also clean your harvester. But if you are, you are concerned, maybe think about and you don't have full sealed storages, but put that first lot of grain into a sealed storage and fumigate it straight away so you ensure you don't get the insect load from the harvester going into the silo. Aeration is another non-chemical tool that is very, I'd say, pretty much vital for oilseeds. You can get by without it, but you are running a risk. It works by obviously cooling seed and drying seed. If it cools the seed, if you can get down to 15 to 20 degrees, you can stop insect breeding and you just slow them down. It also maintains seed quality. We're talking about oil quality, colour, rancidity, a whole lot of things. The other thing it does, it makes it uniform, so you don't get hot spots. It spreads the moisture throughout so it's even. You stop getting hot spots, and you can also prevent moulds forming in high moisture points. There are two types. One of them, cooling, obviously, as the name implies, reduces temperature. For this, it doesn't take much work. So what we've got here is a small motor, half a horsepower, because all you need are fan rates of 2 to 3 litres per second per tonne. Now that per tonne bit is very important. You've got to consider when you're setting it up how much grain is sitting on top of there that you're trying to force that air flow through, because there will be back pressure. Sunflowers are excellent for aeration because they're large seed and there's a lot of easy to flow the air through them. So it's opposite for canola. Now in the fact sheet in your module at the back there's a thing about oilseeds. A lot of that is about canola, and it talks about having high back pressure. Sunflower seeds is quite opposite, and actually it's quite easy to flow through. If you are having a fan on a sealable gas-tight storage, remember the seal on the fan housing, on the lid there. This is that black lip there. It often gets knocked about, and if you're doing a pressure test and it's failing, often that might be just the culprit. Just maintain it, basically. Setting up the ducting inside the silo is a very important task. I have seen some do-it-yourself jobs that are quite good. I've seen some do-it-yourself jobs that are quite shonky and lead to more problems than they're worth, because basically it's that uniform. You want that air to flow through evenly. You don't want it to send all the moisture or the temperature down to one side and end up with condensation problems at the top. Also, when you're thinking about if you are setting up aeration, and you can do these in non-sealable silos, probably a good thing to do for extra protection, but think about the hygiene issues that this ducting puts in. This one here is quite nice in the fact that there's no bolts, so it can actually be lifted up, pushed back and cleaned underneath it, so you can get rid of all that dust that's sitting around in those crevices. So that's an important issue to consider. Also, automatic controllers. Take the work off yourselves. Rely on machinery, hopefully it will work, but now we can get actually automatic controllers that can do up to 40 silos. So this was an old slide, 8 silos, but they're getting more technical at the moment. It's more efficient, and it just takes that extra pressure off you of considering, oh, is it going to rain tonight? It's going to be foggy in the morning. The whole works. It will select the right air. The other form of aeration is drying. Takes more work, so you need a bigger fan, a 10 horsepower motor now we're looking at, because the rates you require are that much higher. It takes a lot more air volume and work to actually draw the moisture out of seed. So we're talking 15 to 25 litres per second per tonne. And it is essential that you have that mark at least to draw the moisture through. Sunflowers are wonderful, again, for drying, ambient drying. You just push the air through. In fact, they're so good that they actually get over-dried more often than under-dried. The thing is, often happens though, is they don't have high enough flow rates, and so the drying front that they're sending through actually stalls, and so you actually just move the moisture from the bottom to halfway through the bulk or to the top. You get condensation about 16% at the top, but you're at 6% down the bottom, and it's over-dried here, it's too moist. You've got to make sure you're flowing through long enough that you get that drying front right the way through. You can smell it from the top, and so it automatically goes through. Again, there are auto controllers now that can switch between the cooling and the drying. Just remember to have the right fan size. You can also get dryers that use external heat. Again, as I've said, sunnies are great for drying. The external heat has to be really carefully monitored. Kevin's experienced at this, and he says you get to about 11% and then you drop off the heat and let it cool naturally, and they will dry an extra 2%. So don't dry to a certain 9% and then switch it off, because that cooling phase will actually have further drying. There's some excellent recommendations in the module on page 7 of the module about external heat drying, just to consider it. Ideally, I would most probably go with the ambient drying rather than the external heat, but if you've got the external dryers, by all means, consider using them. How it works, basically you have a thing called ERH, equilibrium relative humidity. That means basically that the air between the seed has equal to the content, the moisture and temperature in the seed. So it's all the same, basically, all there. Now, if you've got sunflower seed with 9% moisture content, which is about 70% relative humidity at 25 degrees, there's a little table on the custom vac sheet, second last before the vac sheet, that can convert relative humidity to moisture contents as a guide at 25 degrees at least. But so if you've got seed at that moisture content, so that's basically 70% relative humidity. If you get air pumped through at 60% relative humidity, that's actually going to dry the seed. So you're pushing it through. Any air below 70% will actually dry the seed. You push it through, the air is drawn out and equilibrates, and this is what causes that drying front. And you get a series of these drying fronts moving up through the grain until eventually you get a nice even moisture content throughout. Hopefully not over dried down here and just stalled up here. Another thing to remember is that temperature changes in hours or days, so it's a quick process. It's quite easily to get your seed cool, but moisture is days, sometimes weeks, to actually draw it down. So remember that when you're doing it. How does this affect temperature? How does these temperature changes affect insects? Well, basically there was an experiment set up. Again, apologies, it's wheat, not sunflowers, but it's the same. It will be the same thing here. Lesser grain borer was the primary insect, but we're looking at sunflower seeds here. So your main insect is the rust red flower beetle, this guy here. They put 100 insects in at various temperatures at 35 degrees, 35 degrees. You ended up with about 25,000 insects after 8 weeks. Only 8 weeks, only 100 insects, goes up to that high. They love it at that temperature. Their favourite temperature. What's the harvest temperature of sunflower seeds? About 30, 35 degrees. So that's what they're loving. However, if you can get that seed cooled down to 20 degrees, 100 insects in, 100 insects out. Doesn't kill them. Aeration cooling will never kill the insects. It doesn't get cool enough. However, it stops them reproducing. It also slows them down, so you won't get them feeding as much. So you're minimising your damage. They're a bit sluggish. And actually that air movement and the cool temperature might stop them actually migrating in, because they don't like it. It's not warm, it's not moist. There's food, but there's most always something better down the farm next door. If you look at all the insects, basically, they're around that 20 to 18 degree mark. Rice weevil is the lower one. It likes it a bit cooler at 15 degrees. So basically, you can control most of your main pests in there with aeration cooling. Not actually killing them, but stopping them from breeding. And I should say there might be some evolution going on, that they might change regional adaptations. So don't hold these as 100% 20 degrees. They're never going to breed, but it's a good indicator. Is it possible actually to get these temperatures in our silos over summer? Yes, basically, in a word. Now this is wheat. Now I've mentioned many times in this thing, I'm starting to repeat myself, that sunnies are easy to aerate. So they're actually better than wheat. It's easier to get the temperatures down than it is with wheat. So remember that, even though this data is for wheat, we'll try and get some sunny material up but later on. But for now, we've only got wheat. It would most likely be quicker. So what happened where there was 2 silos. One was non-aerated, that's that red line at the top there, and the blue line is actually an aerated silo. We're looking over December, January, and these green lines are the ambient minimum temperatures over that period. And what happened was the grain was put in, the controller was turned on, and whammo, you've got a drop in temperature from 35 degrees down to about 22 degrees. And eventually we ended up about 19 degrees at the end. This is January, February, and this study was done in New South Wales. It was done around mostly central New South Wales or southern New South Wales. And you can see it is definitely possible. If we look at the automatic controllers, this is most probably in maintenance mode. Now we've got the actual temperatures throughout the day, daily temperatures. The green line is the seed temperature, the wheat temperature, and the pink bars are the hours that the fans were in operation using an automatic controller. So you can see there was a couple of hours every so often, a couple of days, 13-hour period because the controller found some cooler air. What happened down here was a rain front went through, and after a rain front you usually get cooler air. Now the controller had stopped, but once that cooler air came through, it found that great pocket of air that it could use, and it ran for 35 hours. Little break, and then another 7-hour period, and got the grain down another 3 or 4 degrees. Maintained that, stopped for a while, it's fine, it's got an automatic, it's got a moving set point, so it actually, once it gets down to a certain point, it starts looking for temperatures higher than it was. And it's maintained, it's actually got down to, now we're looking at 17 degrees, and it slowly makes its way up to about 18 degrees. Again, we're looking over February, so the hottest part of the year basically, and you've got temperature, seed or wheat, down at 20 degrees, stopping those insects and maintaining the quality of the grain. This slide just shows a real-life example of drying and gives the comparison. This is a temperature change. Basically, it was evaporative cooling. The rate of these, we look down here, 27 litres per tonne per second. So it was a big burst of air, dropped the temperature down, and as the seed dries down over several days, weeks, it actually dries down from, we've got it from, well, it's gone from about 90% down to, I think, 18. We got down to 12.8% moisture content. It took a period of days, but it does happen. But again, it's that longer period for drying over a faster period for cooling. On to chemical treatments. This grey, I know you can't read the writing in there. It's basically colour-coded, and you can find it on a website. But basically, these are all the storage chemicals that are available for stored grains. That's grains, wheats, and all the grains. Overall, not very many. If you're looking at sunnies, you're going even less. You can wipe out that whole purple section. They're your protectants, the ones that go on the insects, on the grain. So they're out. You can't use any of those. The green is a diatomaceous earth. That's okay, but it's usually only a structural treatment. That's all right. Spinosad is out. It's not for oil seeds yet. Top two, we've got phosphine and carbon dioxide, and they're effective against all the insects. Dichlorvos is out. So for sunflower seeds, you've got those top two and the green bar. That's it. So it's not many options on your chemical front if you do have an insect problem. And those two that I mentioned, the CO2 and the phosphine, and there's actually now sulfurofluoride and ethyl formate, all require sealed gas-tight storages. We can't keep mentioning gas-tight because a lot of farmers go, it's sealed, I shut the lid. It's not. It's got to actually maintain the gas in there for a period of time. If you're doing a fumigation, do it well. This is the issue we've got at the moment, is resistance. This is where we're finding all the resistance, and this flat grain beetle is now has resistance levels where you can't control it with phosphine anymore. It's getting useless against the resistant ones. And you can see there's red dots of those all throughout the grain growing belt. So just ensure it's a sealed gas-tight structure, and you do it according to the label. A lot of work's gone into those labels to make sure that they kill all the life stages. And we hear so many people say, I did a good job, I killed all the adults. But remember those bits you can't see. If you look at a phosphine fumigation at 25 degrees, if you are measuring it and monitoring the concentrations, basically at 300 parts per million, it takes 7 days to kill those egg stages. If you go higher, 500 to 1,000, phosphine's great because you can manipulate time and concentration to a certain point, but there is a minimum of 5 days it takes to actually kill them. So remember those 7 days or 5 days concentrations, please, because the next slide is going to show you a comparison between sealed and unsealed silos. It was actually the same silo. It's a 120 tonne silo. This one had a half-life, a pressure test of 210 seconds, which means it's a good sealed silo. If you're going to buy a sealed silo, there's an Australian standard out there now. It must make 5 minutes as a half-life. And ensure if you do buy one and you get a manufacturer that he shows that it can work when it's erected on your site. If he doesn't, there's a lot of dodgy ones out there, and they should have a Australian standard sticker on them as well. Anyway, what we had here was, these are the concentrations of phosphine after it was applied, going down the depths. So you've got the headspace basically going down the depths of down to 6.8 metres to the base of that silo. The tablets were put in at the top, sealed up and left. And you can see there's a rush, there's an increase, sharp increase in concentration in the headspace. But down, this is the bottom line, this is at 6.8 metres. It actually doesn't reach that 400, 500 until day 2. So it takes time for that phosphine to actually go down to the bottom. It maintains that for at least 5 days, because a phosphine fumigation on the label is at least 7 days at 25 degrees Celsius. So it actually just manages to make at the base of that silo to actually kill the eggs and all the life stages. Also think about the fact that if you had a bigger silo, that would take longer and you might not actually make it. Remember I said insects are mobile and they will go where it's not so great. Where it is great, if it's not so great, they will move away. Well, they will be moving down to that bottom as the gas penetrates down there. Same silo, what they did was at the lid, they just put 3 clothes wires at the top and then they shut the lid. And basically, it didn't take much, but you got an 8-second half-life. That was as much as they can manage. Basically an unsealed silo. And yep, they got up to 1,000 in the headspace. Same concentration of tablets according to the volume of the silo, not how much was there. They got there, but they didn't maintain it for 5 days. And at the base, this is that baseline, I think it did get above 0. It got to 2 parts per million. But you're certainly not killing the insects down there. So, the lesson here is sealed gas-tight silos if you want to kill all the insects. And you'll need that for sunflower seeds because that's your only option if you do have an insect control problem. There's also now talk on the label of putting a thing if you have a larger silo than 120 tonnes or 150 tonnes that you have recirculation. So actually pumps with aeration, pumps the gas around and through. So a sealed gas-tight storage with aeration is a must.